Okay, so Kevin's now going to talk a little bit about the control system for the new E3 Reflow oven.
Yeah, so there's a lot of systems out there. There's a lot of Arduino designs for toaster oven reflows, but we wanted to do something a little better, a little more advanced. We purchased an oven that had 4 heater elements, 2 top and 2 bottom, to give us more uniform heat flow, heat distribution on our boards. This particular unit also has a recirculating fan on the inside so that you get a little bit of air mixing so that you don't get stagnant hot pockets within the unit. We installed a cooling fan to pull the heat off, and we installed a reference board with a temperature sensor on the top and the bottom to give us a good idea of what heat the boards were seeing. In terms of the control system itself, obviously we ripped out everything on the existing oven. We installed 2 solid-state relays with heat sinks inside the cabinet. We installed our user interface and displays on the front, and then we installed the main control system on the side. The main control system consists of our E3 embedded 4x4 motherboard, and for this particular application we chose the Freescale processor. We added to that a real-time date clock, which we use to track 1-second intervals so that every 1 second we update both our display and the data going out our serial port. We installed a cold junction compensated thermocouple board with a thermocouple. We actually used 2 of these, one for the top and one for the bottom. We installed a buzzer. The buzzer is used to enunciate once we reach the peak temperature on our heat cycle. It also lets us know when we've completed the cool down mode. An RS-232 board to send data out to serial port so that we can capture our reflow characteristics and plot it out on a nice graph. A user interface board that's got switches and LEDs. We use this to select the mode, reflow, cool down, preheat. We use that to dry out moisture sensitive parts and also dry our boards after we wash them, and system reset. And breakout boards. This particular one is configured with 2 cables that we use for remote mounting. The displays and indicators on the front actually have a breakout board sitting behind them. And then they're cabled back to the main control board through our cabinet. The system runs at about a 1 degree C per second heat rate and a 1 degree C per second cool down rate. We actually attended IPC's training on surface mount rework and repair, and as part of that course we discussed how to do solder reflow. For your typical no clean fluxes, 1 degree C per second, especially for your lead-based solder, is more than adequate. We power the system with just a standard 12 volt wall type power supply. This particular unit is regulated, but really we don't care if it isn't. The system accepts anything from 9 to 24 volts in, and then it'll regulate it down to the 5 and 3.3 volts for our peripherals and our processor board. So that's the guts of our control system, and it works extremely well. We've been very happy with it. And like I said, it's a little more advanced than what you would get with your typical Arduino project, a lot more accurate. And we're in the liquid state above 183 degrees C, about 90 seconds, which is about where you want to be with these type reflows.
For more information about the processor independent embedded platform, go to our website, e3embedded.com.